Welcome back to AI-driven personalized and adaptive learning environments course. In this week podcast, we have our TA Jyoti. We will be discussing about the topics we discussed in this class, and Jyoti will be asking questions, and we'll be interacting with that. Yes, Jyoti.
Yeah, welcome you all. I have watched all videos of week 3. So in the week 3 it is about the learners model. So I have listed some questionnaire that I had the doubts about that while learning that learner models. So I'll ask one by one the questions. Might learners will also help about that. So in week 3 lectures, you discussed about the learners actions and the learners model layers. Can you elaborate more about the hidden layers?
Okay,
Uh,
so in week 3, we talked about learner models. We say that learners exhibit some actions which is observable. For example, learner is watching the video. After watching the video, moving to the to answer the questions, or playing the video, pause the video, or reading the content, highlighting the content. Those interactions are observable. Okay, we can observe those interactions, but from these observable interactions, can we identify their hidden state, that is their skill mastery? Can we identify their knowledge gain throughout this particular interaction? It is the hidden node. The concept is that we take this observable actions, that is the lower bottom of this learner model, combine them into meaningful actions. For example, a student is raw data says the student at 10:01 was reading the page, then at 10:02 started highlighting. Then you can combine together, like student was reading for 2 minutes, student highlighted a particular content related to a question. So those kind of annotation can happen in the second layer. By using this, you could apply some of the learning analytics tech, for example sequential pattern mining, that would tell the learner really understood the concept or not. In the IRT, this is basically the learner ability data. Or in the next week, we'll see the BKT. In that, it will be the learner's skill mastery score or knowledge tracing. So that's the idea.
Okay. So the next question is about the in your lecture you describes about the learner models constantly updating. So dynamic digital representation of the students. So what are the practical challenges of keeping this model truly dynamic? What challenges you can
Good,
see?
very good. I think we said dynamically, we can't updating the learner model at every question, right? So we need to have a breakdown of chunks. If we give a bigger topic, I have to chunk into smaller 3 topics or 4 topics from the big topic. Each topic should have their own assessments. They practically try to understand the learner's knowledge in all the assessment questions in a particular chunk, then update. A particular chunk might cover 3 or 4 concepts. Those concepts are understood by set of questions. So as set of questions, when you feel that these questions are enough to analyze or measure the learner's ability on the particular concept, then you do this analysis, like update process. If you try to update at every moment, you will not be able to do the learner's ability. But if the learner model is capturing the affective state, for example, I'm trying to capture the learner's affective states like boredom, confusion by using the facial expressions camera, there we need to react immediately. In the sense, a camera is usually 25 frames per second, which means 40 milliseconds we get some data. If you see the student is in the every 40 milliseconds, like in a second the student is in boredom or confusion state, then we no need to wait till the concept to cover. Maybe wait for that particular period of say 2 seconds or 3 seconds. Then you have a pedagogy logic says, hey, if a student is confused, I'm going to give some feedback. Here waiting is not valid. So sometimes it is dynamic for the case like this. In some places like assessment, learnerability, we might need to based on chunk. Practically, we keep the assessment cognitive things separate, affective things separate. Sometimes we include also motivation, that is another separate actions. So that's the idea.
Okay, thank you. So this is about the e-learning systems. So
Yes.
what about the challenges in the real-time classrooms?
So I think we'll be talking about a real-time classroom very way back. I think after long back in this course, we cannot do the personalized adaptive learning as we do personalized each individual in the real classroom. What we do, we try to collect the students' interaction in the class using web camera and the audio mic. We can collect it. We can provide a dashboard to the teacher. Teacher can look at it. Now teacher have autonomy to decide, should I intervene, immediately, or should I wait for the students to get confused, the productive failure, the productive struggle, you say, no? Productive struggle is fine, let them go, then I intervene. That is a teacher's thing. So here we don't maintain the learner model in the classroom environment directly. So in the web-based or computer-based, yes, we do.
Yeah, as you mentioned, there are different states of learners, that
Yes.
cognitive state, behavioral
Yes.
states, and the affective states. So how do you model this learn? How do you make the learner models using these different
Okay.
states?
See, I think there are, we call ABC, like
Yeah.
affective, behavioral, and cognitive states. Um, that when you say affective states, we are talking about affective states in the sense like the learner-centric emotions. It's called boredom, confusion, surprise. I think we'll be talking about it in detail later. So in order to address that, we need to use a web camera, and there are lot of new advancement in technology has come. We have latest deep layers available. We could use Russell's framework on Valence Housel model to detect the students' learner-centric emotions like boredom, confusion. That will be done by the web camera. Now what we do, most of the analysis is done in the browser, because we don't want to send all the data to the client. We keep it in the browser. With the browser does all the analysis. We use MediaPipe kind of framework from Google, so that it does all those object detection, facial key points extraction. Only metadata is sent to the particular algorithm. It detects whether the student is boredom or not. So that is done by the web camera. That is a bit complex. Whereas cognition is the up to you designer, and say that I want to measure the learner in this particular topic. I have a set of questions to assess the student knowledge. So if a designer decides that rules, then the learner model tells you how much it is. So cognition is the easiest to do that way. Affect will be the camera. Behavior is the easiest of all. In the sense, you just have to know the student is in the system or not. It's like in the classroom, is the student present or not? If they present, it's plus, otherwise no. That's all. It's very simple like that.
So which is the hardest model?
I think behavioral is easiest. The hardest would be the affective states. The reason cognitive states, as a designer, you would know that I wanted to measure this particular skill using set of questions. Whereas behavior, we know the student is in the system or not. But affective, even the model which talk about latest model like Russell's model, it works for a particular context. Okay, the same model is not for other context. For example, I cannot do the same model trained in the other country to in India. Even in India, I cannot use the same model trained in the class 6 students to undergraduate students. So I need to train for every time, every system. So the affect is the one of the hardest among all this thing direction, even with the latest advancement and Gen AI.
Yeah, in this week 3, we have talked about the IRT. So, some questions are based on the IRT. So, the lecture states that the IRT was designed for the summative assessment, not for the formative assessment. So, what is this distinction mean?
I think in general, what is summative and formative, you might know, right?
Yeah,
In summative, the end of semester exams are called summative exams, because we want to let the student to go through the exam, either mid-sem or end-sem, just to know what is the overall knowledge learner gained from the overall the period. But formative assessment are mostly, it happens in the class or the weekly quizzes suddenly, just to understand where the student current state, so that the teacher could adapt and do it. IRT in the paper we discussed is used as a summative.
summative.
But it's not necessarily you have to use summative. You can use IRT also as a formative if you want to use it in the classroom and quickly understand and give feedback. What I mean IRT as a summative in the sense, uh, we cannot use IRT to you know to learn, give feedback, and to give feedback to the learners. IIT can be measured students' current ability and matching question with the based on difficulty. Whereas we go for the BKT, later we talk about other models. It is used to do productive, the feedbacks, hints based on the student's response. So that was a difference, but it is used summative for this paper, but it is possible to use in the formative also.
So how does it matter in the personalized adaptive learning?
In a personalized adaptive learning, I would not recommend IIT for the learning purpose. IIT can be used for the assessing purpose. Use IIT in the assessing purpose where the question is dynamically adapted based on the learner ability. So where based on the learner's performance in the current question, you match it, then you dynamically update it. So in adaptive question and answering, perfectly IIT is best. In a personalized learning environment where you want to understand the learner's knowledge in a particular concept or a particular course, then give a feedback, there IIT happens at the end, then it's not good. And IIT is not telling why the student failed, what kind of remedial content is not clear. So we will not use IIT in that case. So my suggestion for IIT, use it as a question and answer, mock test, students'
the
knowledge.
formative assessment.
Yeah, that is. Formative or summative, depends on your time.
Okay,
Yeah.
thank you. Now we are in an AI era, so I
Yes.
would like to ask the questions about the AI, that how AI can help to design this learner model.
Okay, this is the thing. The learner model we saw in the IIT in this week is all about learners' ability to answer the questions and the difficulty level setting, right? So can AI do that? It can do. We can use AI to come up with its own new algorithm. We could, create a new one. Where AI can be used is that if I have a data of a students answering set of questions, I have 1,000 students answering say 100 questions, and we know the students spent on time on each of the questions, say 10 seconds, 5 seconds, or something like that. If and I know which answer the student is answering wrong. If I have all this data with the question type, option detail, and what kind of option students are, time spent on each question, AI would be able to come up with a fantastic learners misconception, which question is really tough, which question a lot of students are struggling, they're spending a lot of time still failing, some questions students spending no time, they're easy for them. That kind of analysis can come into AI. It's not about IIT. Gen AI can create with respect to IIT, it can create a fantastic bug library or misconception library, and it can help you assess your questions also.
So,
Okay.
so thank you very much.
Yeah.
So hope learner will understand this week 3 course and hope their doubts are clear.
Thank
Thank
you.
you.